Hey guys, today this is the optional modeling sinusoids day 2. So this is just some more practice problems using our writing equations of sine and cosine graphs. So I'm going to go through 2 different examples. Feel free to stop and pause whenever you need some extra help. And here we go. Naturalists find that the populations of some kind of predatory animals vary periodically, and so periodically is the same thing as sinusoidally. The populations of coyotes was tracked for several years in this county, I'm not going to try to butcher it, Colorado, starting at time t equals 0 years. Records indicate that a minimum number, 200 coyotes, occurred when t equals 2.9 years. The next maximum, 800 coyotes, occurred at t equals 5.9 years. Sketch a graph of the sinusoid. Now you should always try to sketch a graph of your sinusoid, just because it gets confusing if all you're trying to do is write an equation and you don't have a picture to look at. So always try to figure out what your picture looks like. So I'm going to use all the information that they gave me in the beginning to make a graph. So time is usually going to be on your your x-axis. I was writing y at that time. So my time is years, and then that means that my y-axis is going to be the population or the number of coyotes. I'm going to go ahead and put in those special points that they told me. So they told me 2.9 years was important, and then they told me that 5.9 years is important. Okay, and then they also told me that the maximum number happened at 800, and that was at 5.9 years, and then that the minimum number happened at 200, and that was in 2.9 years. Okay, and so with this, I don't have a full cycle. I know that it's a periodic function, but I don't have a complete cycle to look at. But knowing this information, I can infer that it took me 3 years to reach that next higher low point. So 3 years after 5.9 would be 8.9, and since it was at a maximum, it would be at a minimum. So I'm going to go ahead and use that to draw my graph. You do have to make a couple of assumptions when you're doing these types of problems. Okay, so there's my graph. I'm going to go ahead now and figure out what my equation would look like. So the first thing I'm going to go ahead and find would be the values on my y-axis. So for my c value, remember it's going to be that midline. And so if I went halfway in between these two, I could do my average. So 800 plus 200 divided by 2 would get me 1,000 divided by 2, or 500. So that new sinusoidal axis would be at 500, the midline, which would then make my amplitude to figure out the distance from the top down to the middle, or from the bottom up to the middle, would be 800 to 500 would be 300. Okay, and now I'm going to find those x-axis values, and that's my period first. So I'm going to take 2 pi and divide it by whatever my period is, how long a cycle takes. So a cycle would go from a high to a high, or a low to a low. And so to get from 2.9 to 8.9, I would take 6 years to get there. So 2 pi over 6, which would simplify down to be pi over 3. Okay, the last thing I can do then is my sine, or my d value. I don't even know where I was saying sine. And I can do this a couple ways. Cosine, remember, starts at a high, and that would be at 5.9 years. Or I could write this as a negative cosine graph, because if I have a low point at 2.9, or I have another low point at 8.9, depending on where you want to go. Okay, so that would make my equation for part B. So that was part A. Part B would be y equals 500 plus 300. We're just following that general formula. Cosine pi over 3 times x minus 5.9. Okay, and I did all that work up there. Okay, now we want to figure out what the population is when t equals 7 years, or when x equals 7 years. I can go ahead and use my calculator for this. So if I go ahead in my calculator and I type in my equation into y1, again, I found that it was 500 plus 300 cosine alpha y equals, makes me a fraction, pi over 3. Okay, x minus 5.9. Now remember, if you wanted to look at this graph, you need to make sure that your window is good. And so for my window, I'm going to just go ahead and make my x min 0, because I don't care about time being less than 0. my X max we said was 8.9 years. But if I want to think about this, if 6 years is a cycle, if I take 2.9, which was my starting, plus that 6-year cycle and maybe put in like 2 or 3 cycles, that would get me my starting plus a couple of periods in there. And then you can make your scale be whatever you want. I'll make it 3 just because. My Y min, they never went negative. And then my Y max, it would be 800. Or you could go ahead and make this one 200 if it makes you feel better. Okay, and then let's just make my scale by 100. So I think this is the hardest part about doing this, is trying to figure out what your window should be. Here's my beautiful graph of coyotes. Cool, great. And then again, I care when X is 7. So if I go to second trace, value, X equals 7, I would find that there were about 622 coyotes at that time. I'm not going to round that. I'm just going to round it to a whole number because coyotes, not feet, can't have part of a coyote. That'd be weird. Coyotes are declared to be an endangered species when their population drops below 300. So if it's below 300, bad news bears. Between what two non-negative values of t were the coyotes first endangered? So that's why it's kind of nice that we have my graph already in my calculator, because I care about where y is equal to 300. It's a bad thing if it goes below that. So if I go into my y equals and into y2, I type y2 equals 300 and I graph it, I want to know what are these two values, because this is where my graph dips below that 300 mark. So this is the 300 coyotes. And so this is the first value I want, and then I want this value. And so I can go into my calculator and I can do second trace, number 5. I'm going to just have to scroll over. It's like I want to be in the middle here and not want to let you scroll. There you go. There you go. It's over there somewhere. Here it is. And then I'm going to press enter 3 times. And then I find that that first value is 2.096. So 2.097 would round up. And then my second value, second trace, number 5, same thing, but we go over to the other one, enter, 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 and I find that that is at about 3.703. And I wrote seconds. That should be years. I was too used to doing stuff in seconds, apparently. Doesn't make any sense. Coyotes are under 300 after seconds. Okay? Again, so when you're doing this, figure out, are they asking you for an X or a Y? Use your calculator. Let's try that second question about a tsunami. So a tsunami is a fast-moving ocean wave caused by an underwater earthquake. The water first goes down from its normal level, so it starts by going down, then rises an equal distance above its normal level, and finally returns to its normal level. That normal level sounds a lot like my vertical shift. The period is about 15 minutes. Suppose that a tsunami with an amplitude of 10 meters approaches the pier at Honolulu Bay, where the normal depth of the water is 9 meters. And we just said that sounded a lot like my vertical shift. Assume the depth of the water varies sinusoidally with time. Okay, the first thing it asks me to do is predict the depth of the water. Well, that's nice and all, but before I can do that, I need an equation. And before I can do that, I need a picture. And so always, always, always try to draw the graph and then write the equation, even if it doesn't explicitly ask you. Otherwise, you're probably going to miss the questions. Okay, so looking at this, we're going to go ahead and draw my sinusoidal graph. This is time on my x-axis, and this is measured in minutes, not seconds or years. And then my y-axis would then be the depth of the water, and they're measuring that in meters. Okay, and so now I'm going to mark off those important points that they told me. The first thing that they told me was that the normal depth is 9 meters. And then they also told me that the amplitude, how high and how low it goes, would be 10 above and 10 below. So 10 above 9 is 19. 10 below 9 is -1. Okay, well, I'm not really happy where my 9 is, but whatever. So again, this is your normal level of your water. Then they tell you some times. The first time that they tell you is that the period is 15 minutes. So it's going to start at its normal level. Starting would be right here at 0, and after 15 minutes, it's going to get back to that point. So if you remember, with sinusoidal functions, we're going to have 4 different critical points in here. So in order for it to have gone up and then gone to the middle, that would be half of 15, so that would be 7.5. And then to get right here up to a top point, that would be half of that, so 3.75, or you could have taken 15 and divided it by 4. And then another half, so they could get down to that low point, would be 7.5 plus 3.75, which would get me 11.25, or just take half of it again. Wow, I'm going to give up on that part. Okay. Well, I got pretty close. Okay, so that would be the picture of my sinusoid, and it has all the information I need in here. So let's go ahead and then name all of the pieces so I can write the equation. So A, the amplitude, they already told me was 10. They even said it. They said amplitude. Okay, and then C, that middle point here was at 9, that normal depth. B, we're going to take 2 pi and divide it by my cycle length, or my period. And so it took 15 minutes to get there. And remember, that was in the problem. Can't simplify that down. And D, there's a couple ways we can do this. If I wanted to write this as a cosine graph, I would go to that high point, and that is, oh boy, did I draw this the wrong way? I did. It's supposed to be going down and then up. I wonder if anyone caught that. Okay, sorry, it went down and then it went up. I was not reading my question very well. So it did this. So all my first values will be the same, but it'll just change where my starting values are. So my cosine then would start at a high point, which is at 11.25. But I could also use this as a sine graph. And a sine graph, remember, is a middle going up. So that would be at that halfway point, 7.5. Or I could take a negative sign and do it at one of those middle points that go down. So that would be at 0. Okay, so again, there's lots of different ways to write this equation. I'm going to go ahead and write it with the 0 because that makes my life easier. So I would have C. This is negative sign, so minus 10 sine of 2 pi over 15 times x. Okay, and again, you could have written this as cosine of x plus 11.25. It would get you the same answer in the end. So now that I have an equation, I can go ahead and figure out all these pieces of information. So part A asks me to predict the depth of the water at 2 minutes. So I go ahead and I can just use my calculator for this. Let me go clear this out and make my new beautiful graph in here. So 9 minus 10 times the sine, 2 pi over 15, all times x. Okay, right here. And again, you got to change your window, make sure that it actually makes sense for this problem. So we go from 0 to 15. If you wanted to make a couple cycles, you could do like 15 times 2 or 15 times 3. I'll just do 2. I can make my x scale, I'll just make it 10. My y minimum, remember, it went down to that -1 and it went up to 19. And I'll just make it count by 2s. Okay, and then I'm going to look at my graph. And they want where x is 2. So I'm going to do second trace, x equals, second trace, enter, x equals 2. And I would find out that the depth of the water right there would be at about 1.569 meters. Okay, part B asks me to predict the depth when x equals 12. So same procedure here, just do second trace, number 1, x equals 12. And I would find out that it was almost at its peak, 18.511 meters. Okay, so that was part B and A. Now letter C says, according to your model, what will the minimum depth of the water be? And so you could look at your calculator and see it, or you just look at your graph, and you would see that that minimum depth would be -1. Or I was trying to write feet, it's meters. Well, that looks like an M sort of. It asks then, how do you interpret this answer in terms of what will happen in the real world? Well, if I'm thinking about this wave going someplace and it was -1 meters of depth, that would mean this right here, this is like the ground. This is the ocean. This is the bottom of the ocean. And so my wave is underneath the ocean. And that doesn't really make sense. So the water would be below the ocean. So if it doesn't make sense, then that means it's not applicable in the real world. So in real life, not necessarily according to our model, the minimum would just be 0. Because it doesn't make sense to be going below the bottom of the ocean. Okay, that just is weird. Finally, D, for how long will there be no water at the pier? And so this is asking you about that y equals 0 point. They want to know how long is this happening. So I can go into my calculator, type into y2, y equals 0, go to my graph. It did actually graph, contrary to popular belief, and I'm going to go ahead and I'm going to change my window a little bit so I can see a little bit more, because this is killing me a little bit to have that text all up in front. And then I'm going to go to second trace, number 5, and then I'm going to go find that curve. Here we go. Enter, enter, enter. I find that that first point is at 2.67. And then the next point is going to be second trace, number 5. Go over to the second part, close enough. And I find that it ended at 4.82 or 83. And since this is in minutes, this is time. So between those two values, there's no water at the pier. Okay, I hope that helped you out with your real world graphs. Again, I know these can be kind of beastly, but if you can draw the picture, then you can find the equation and then you can answer any sort of question that they may ask you about it. Have a great day.